Hello, and welcome to the trig inverses solving day 3 video. You may notice that I'm starting this more like my normal videos as opposed to the last few. That's because I'm filming this in the now time and not in the springtime. This is going to be a video with just 3 example problems to go over. Nothing necessarily new over the last from the last few days, but it's going to be a good idea to follow along, and hopefully this video will be quick. So like I said, we are focusing on solving day 3. The next few days are going to be about evaluating, so we'll talk about that later. Let's get to our 3 examples. So the first one is going to be the square root of 3 times cosecant of theta minus 2 is equal to 0. Now I look at this and I go, oh, cosecant! I've completely forgotten about that. Yeah, we're not getting through this unit without our cosecant, secant, and cotangent. So let's figure out how to deal with that. So from here, I'm going to add 2 to both sides and get square root of 3 times, whoops, there's so many c's, cosecant of theta is equal to 2. And then I'm going to divide everything by square root of 3. So we get cosecant of theta is equal to 2 divided by square root of 3. So there are a few different ways you can deal with this. You can start by rationalizing the denominator, or multiplying top and bottom by square root of 3, and then dealing with cosecant from there. But I go, you know what, cosecant, I know I can turn that into something with sine, and that's going to make my life way, way easier. So I'm going to do just a few kind of side examples of what I'm going to ask you to do. So if we have something like 1 over x is equal to 1 over 3, if I flip both of these fractions, the equation's still equivalent. I get x over 1 is equal to 3 over 1. I get the same thing or the same value. So if I had something like sine of pi over 6 is equal to 1/2, something that's true, if the sine is over 1, if I was to take this and flip it, I'm going to end up with 1 over sine, also known as cosecant, of pi over 6 is equal to 1/2, or the flip of that. So that's what I'm going to be doing, but the other way. So I can say that cosecant is 1 over sine of theta is equal to 2 over square root of 3. And now I can flip both of these fractions and end up with sine of theta over 1, or just sine of theta, is equal to square root of 3 over 2. And oh, I recognize that. So feel free to take that extra step. However, if you just want to go straight from cosecant to sine, just like that, I'm okay if you skip that step in between. If it helps you to write that out, feel free to do that. But now that I'm here, we can just solve like we have been doing for the last few days. So let's see, we'll have theta is equal to sine inverse of square root of 3 over 2, or at what angle is the y value square root of 3 over 2? And we're going to get pi over 3 and 2 pi over 3. Do not forget to write your answers in a solution set. And there you have it. First example. This is similar to something that you may see in the Go Formative for tomorrow. But let's take a look at example number 2. Let's see, example number 2, I'm going to move this up just a bit. I'll leave the answers for you to see. Example 2 is going to be 3 secant squared of theta minus 4 is equal to 0. So I actually think that we did one similar to this in one of our past Go Formatives, but instead of using sine, cosine, or tangent like we have been using, now we're dealing with secant. So from here, I'm going to add 4 to both sides. Get the 3 secant squared of theta is equal to 4. Divide both sides by 3. Now, to get rid of that squared, I'm going to square root both sides. And again, just as I have been saying, please make sure that you do not forget that plus or minus out in front, or else you're going to lose half of your solutions. Wow, that's a weird 3. Okay, there we go. Okay, so from here, once I simplify this a bit, I get secant of theta is equal to the positive and negative version of the square root of 4, which is 2, over the square root of 3, which is just square root of 3. So from here, I can just, flip everything. I know secant is the flip of cosine of theta, and if I take 2 over the square root of 3 and I flip that, I get square root of 3 over 2. If you want, you can kind of put an in-between step where you have 1 over cosine of theta is equal to positive negative version of 2 over square root of 3. And you can flip those, and that's just going to bring you back to here. So again, you can include that step if you want to, if that makes more sense to you. However, I'm okay if you just go straight from secant to cosine. But once we're here, again, I like to write these out as 2 separate steps or 2 separate equations so that I can keep track. So we have cosine of theta is equal to positive square root of 3, and cosine of theta is equal to negative, square root of 3 over 2, and negative square root of 3 over 2. So let's cosine inverse both of these. And so what we're saying is at this angle, when is our x value positive square root of 3? And that's going to be, or at what angle? It's going to be at pi over 6 and 11 pi over 6. And at what angle is our x value negative square root of 3 over 2? That's going to be 5 pi over 6 and 7 pi over 6. And remember, when we write our answer in a solution set, you want to write it from least to greatest. So we're going to have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. There you go. So that's example 2. I really like this problem because we deal with a square root, we deal with something that's not sine or cosine, we have multiple answers. I think this is a cool one. If you can do this, I think you're going to do okay. We have one more left, and I'm mostly doing this one just because I personally, as a math teacher, I'm like, this is fun to do. You may hate me after this. I'm fine with it. So let's take a look at example number 3. Example number 3 is going to be tangent squared of 3 theta is equal to 3. The actual solving of this problem is not too terrible. We're going to start by square rooting both sides so that we have tangent of 3 theta is equal to the positive and negative version of the square root of 3. So I'm actually going to write this as 2 separate pieces. So tangent of 3 theta is equal to positive square root of 3. And tangent of 3 theta is equal to negative square root of 3. And then when I use tangent inverse for both of these equations on both sides, 3 theta is equal to tangent inverse of square root of 3. And 3 theta is equal to tangent inverse of negative square root of 3. So just a reminder, when we have a double angle, we're looking for the total number of solutions within 0 to 4 pi, or 2 full rotations. Since we're dealing with a 3 or a triple angle, we want all of our answers to be between 0 and 6 pi, or 3 full rotations. So first, tangent of pi over 3. Well, let's see. 3 theta is equal to tangent of square root of 3. So that is going to be sine over cosine. It's going to be when your y value is square root of 3 over 2. And your x value, or cosine, is 1/2. And that's going to happen at pi over 3. If we were to take a look at a unit circle, I'm going to kind of very quickly sketch one over here off in the corner. So we have, pi over 3 right here. This is when we have 1/2 square root of 3 over 2. So in this case, sine over cosine is going to give us square root of 3 over 2. Now, the only other place that we're going to have this on our unit circle is if we go all the way around plus pi. I don't know if all of you made it to the end of the last video because you were not required to, but I did talk about how all answers for tangent only have a distance of pi, because if we come over here in the negative version at 4 pi over 3, well, the coordinate here is negative 1/2 negative square root of 3. So a negative divided by negative is still going to give us a positive, so we're going to have those same values. So what I'm going to do is I'm going to take pi over 3. I'm going to add pi to that and get 4 pi over 3. So those are my two answers that I'm going to have for my first rotation. And then I'm going to keep adding pi over 3 to go all the way around. So if I add pi over 3 again, I get, or pardon me, if I add pi again, or 3 pi over 3, I get 7 pi over 3. If I keep going, I get 10 pi over 3. So, okay, we have first rotation, we have second rotation, and we need our third rotation. So now we're going to, sorry, I muted myself. Now we're going to have 13 pi over 3 and 16 pi over 3. And this is going to be our third rotation. So we have all of our answers for all three of our rotations. Remember, this was only for the positive answer. We still have our negative answer to go. So in this case, oh, I also just noticed there's like a random parenthesis for no reason. There we go. In this case, when we have a negative square root of 3, it's when either that x value or that y value is negative. So that's going to be taking place if we go back over here. So this is a negative 1/2, positive 3 pi over 2, and this is at 2 pi over 3. And then if we add pi to that, or go all the way across our unit circle to 5 pi over 3, this is positive 1/2, negative square root of 3 over 2. So for our negative answer, this is going to be 3 theta is equal to, let's see, 2 pi over 3, 5 pi over 3. So there's our first rotation. Keep adding 3 pi over 3. Oops, just happened. I don't know if that continued on. I'm so sorry. I hit something. You may have just seen a bunch of blank screens. I apologize. But we're going to keep adding pi. So this is going to be 8 pi over 3, 11 pi over 3, second rotation. Keep on going, and that's going to give us 14 pi over 3 and 17 pi over 3, or our third rotation there. So we have all of our rotations, all the answers for those. You'll notice this problem's going to have 12 answers. That's why I find it to be fun. And then we still have to take everything and multiply it by 1/3. So I'm going to take all this, multiply it by 1/3 so we can get theta by itself. And we're going to get, let's see, move this up. Theta is equal to pi over 9, 4 pi over 9, 7 pi over 9, 10 pi over 9, 13 pi over 9, and 16 pi over 9. None of those can be reduced. And then for our negative version, we'll have theta is equal to 2 pi over 9, 5 pi over 9. It's basically all of these just over 9. And again, none of these will reduce, but you will notice that our final answers here are all between 0 and 2 pi. So that's exactly how we want our final answers. Last but not least, make sure that you put this in a solution set in order from least to greatest. So we're going to have pi over 9, whoops, 2 pi over 9, 4 pi over 9, 5 pi over 9, 7 pi over 9, 8 pi over 9, 10 pi over 9, 11 pi over 9, thank you for sticking with me, 13 pi over 9, 14 pi over 9, 16 pi over 9, and 17 pi over 9. Woo! Absolutely love it. So this is our final answer. I'm not going to give you one like this on the Go Formative. I just wanted to show you that this is where we could be, and I believe that you can do it. So make sure you stay your unit circle. Let me know if you have any questions. I look forward to seeing you tomorrow. Oh my goodness, I don't know